Let's take a look at solving exponential equations by equating exponents. First, do you agree that if the bases on both sides of this equation are 5, then x must be -6? If x is anything else other than -6, then this would not be equal to each other. So therefore, x is -6. We can check this by substituting back in here to the exponent. 5 to the -6 equals 5 to the -6. That's true. So that's our check. And we're done. So as you can see, equating exponents can be a very nice process. Before we get started on our first example, let's take a look here at this chart. 2 squared is 4, cubed is 8, fourth is 16. So you probably know this up through 16. With a little practice, you'll be able to remember to the 5th and 6th powers, or the 32 and 64. But you also should know these very common bases with common exponents. So you'll notice to the 2nd to the 3rd exists in all of these. Here, 3 to the 4th. So you need to know these. And the reason why you need to is because when you see 81 or 64, you should know what your options are for bases. So 81 doesn't exist in other values here, but 81 really is 9 squared. 64 appears twice on this page. It's 2 to the 6th and it's 4 to the 3rd. And so when you see a 64, you're going to have some options for what base to use. 3 to the -x equals something. Now, since this base is 3, it would be wonderful if we could use a base of 3 on this side. Well, let's check. 3 times 3 is 9, and times 3 is 27, times 3 is 81. So on the right, we have 3 to the 4th. Now, if you knew those exponential equivalents on the previous page, you would have already known that this was 3 to the 4th. Because we have like bases, we can equate the exponents. So that gives us -x equals 4. We're going to divide by -1 on both sides, and that gives us x to the -4. Let's check that. When we put a -4 here into this exponent, we get minus a -4, which is +4. That gives you 3 to the 4 here and here. So that works, and this is our final solution. Here's one that has a little bit more interesting exponent here in x plus 3, and here we've got a fraction. But we know whenever we've got any number or variable within a rational expression, we can move it within that fraction just by changing the exponent. So on the left, we keep 5 to the x plus 3, but on the right, we get 5 to the -1. Now, because we have like bases, we can pull the exponents off and set x plus 3 equal to -1. Let's subtract 3 from both sides. That gives us x equals -4. Let's go ahead and check that. Put the -4 into the exponent. -4 plus 3 is -1, so we get 5 to the -1 equals 5 to the -1. That checks out as true. So our final answer then is x to the -4. Now it's time for you to try that. Here you've got a 9 raised to some exponent, a 27 raised to some exponent. See if you can find like bases so that you can equate exponents. Pause the video and hit play when you're ready to continue. Okay, you may need a hint. So both of these are powers of 3. 9 is really 3 squared. Keep that exponent. 27 is 3 cubed, and keep that exponent. Now pause the video and see if you can keep going. Okay, you want another hint. Here's the original problem. This is what we did on the last page. So you have 3 squared, same exponent, 3 cubed, same exponent as you see up here. So the next step that you want to do is take this exponent and multiply it in. This is the superpower rule, remember? Superpowers get to multiply And when you multiply, you're going to multiply each of those in. So you get 2 times this and 3 times that. So go ahead, pause the video, and see if you can solve it the rest of the way. This is what we had on the previous page. Now I'll walk you through the rest. 2 gets multiplied into this exponent. 2 times negative x, negative 2x, 2 times 15 plus 30. 3 raised to the 3 times x. We have like bases, so we're going to be able to equate these exponents. So let's go ahead and pull them out. Negative 2x plus 30 equals 3x. Let's add 2x to both sides. When you do that, you get 30 equals 5x. Now divide by 5, and you get x equals 6. Let's check that. For this one, you might want to write it down. 9 to the negative 6 plus 15, is that equal 27 raised to the 6? So 9 raised to the 9th power as that equal to 27 to the 6. And that's the question we're trying to answer. Now you've got 2 options. You can keep going and simplifying this, making like bases of 3, or you can just use your calculator, because on the gateway exams, remember, you're going to have a scientific calculator to use. So find 9 raised to the 9th power and 27 raised to the 6th power, and do you get the same answer? If you already did it, you will find that that's 387,420,489. And at that point, you're going, holy smokes. But don't worry, as long as the number is the same, then you're done. So this, folks, is our answer. Now for our answers, you may also put them in set notation, where you put the solutions within braces. Either one of these is okay with me. So that's it for today. I highly recommend you go look in your book on page 434. That's page 434. And try some of the odd problems and see how you can do. Hope you're having a great day.